Okay, here we go. Lesson 1. Angles and steepness. Let's solve problems about right triangles. So 1.1 is called ratios galore. It says triangle ABC is similar to triangle DEF. And they also say write as many equations as you can to describe the relationships between the sides and angles of the two triangles. Okay. I want to dissect this problem before we jump into it. So first of all, we're starting with the ABC. It's similar to DEF. What does similar mean? I want to get you in the habit of like underlining, circling, starring, or highlighting like the key points. So, similarity. The official definition of similarity is a sequence of rigid transformations and dilations. So it's a sequence of rigid transformations and dilations that takes one to the other. The other facts about similarity is the two figures, almost always two figures, they'll have the same shape. The corresponding angles are congruent. So the corresponding angles are congruent. The corresponding sides are in proportion. So the corresponding sides are in proportion. This is can be represented by, let's call it the scale factor. So the sides are in proportion, the same proportion. The angles, corresponding angles are congruent. So our goal in this one, the action of this question, is to write. So we have to write something. What do we write? Well, we write as many equations as you can. Well, I'd say like within 5-10 minutes. Don't spend too much time on this, but you gotta write as many equations as you can. I'm gonna set like a 3-minute timer. Let's see how many I can come up with. 3 minutes, as many as I can in 3 minutes. Okay, here we go. All right, angle C, congruent to angle F. So 1, angle C, congruent to angle F. 2, angle E, congruent to angle B. Third one, angle D, let's just assume this is a right triangle, congruent to angle A. All right, number 4. I know that, let's say we're going from small to big. I know that FD times your scale factor will equal AC. Now that is just the formula A times scale factor equals A prime. Now we're going to start calling scale factor K, because that's what the book does repeatedly over the next few weeks. So FD times your scale factor equals AC. All right, let's go a fifth. Let's start comparing sides. So AC over FD, so this side divided by this side. Remember the ratio of the sides. Corresponding sides are always going to be in the same ratio or in the same proportion. So this divided by this will equal this divided by this. AB over DE. There's his fifth. Still got a minute. Let's go 6. Let's do you can also compare like this side divided by this side in the same triangle. You can compare it as long as you match them up. So watch this. You can go AC over AB equals FD over DE. Try to get the right order too. Okay, let's do a 7th. I got about a minute, or barely any. Okay, so we did that. Oh yeah, here's a good one. Angle A plus angle B plus angle C equals 180. That's the triangle sum theorem. Let's look at this. Angle F plus angle E equals 90 degrees. Because the acute angles will add up to 90. Now this is assuming, of course, that you give me the benefit of the doubt that this is a 90-degree angle. Anyway, that was 3 minutes. I came up with 8. Your job is to come up with as many equations as you can. If you gave me 20 minutes, I mean, I got 8 in 3. And if I didn't have to talk through them, I could probably get 10 every 3. So if you gave me 20 minutes, I could probably get 60. If you gave me an hour, I could probably get 100. Easy. There's so many equations that you can write. But there's 8 examples. All right, moving on to 1.2. It's called Can You Calculate? Let's read it. Find the values of x, there's x, y, there's y, and z. If there is not enough information, what else do you need to know? Well, let me just look at these first 2 triangles. I like to add some color, if you don't mind. I'm gonna take my time. There's no need to rush. I want you to envision geometry as like a stress reducer. One of the ways you can lower your stress is through taking your time, color and stuff. Like slow the world down a little bit. Here's an orange one, here's a blue one. I just bought 2 new coloring books that are displayed in class, so if you ever just need a break from all the stress of math class, you can always just get one of those coloring books. I'm okay with that. But all right, we got an orange triangle, we got a blue one. These 2 I know I can easily find the missing side lengths, because I taught you the arguably the most important theorem in geometry, which is called Pythagorean theorem. And the crazy fun thing about Pythagorean theorem is it's pretty simple how Pythagoras discovered it, and it's really cool. It's just like a clever little trick. I don't know how he came up with it, but anyway, go back to lesson 14, unit 3. So 3:14 for the proof, and you'll see just how simple the proof was, and this guy's like super famous because of it. But anyway, Pythagorean theorem is a squared plus b squared equals c squared, which essentially means the sum of the legs squared. So, in other words, 3 squared plus 5 squared, a squared plus b squared, 3 squared plus 5 squared equals c squared, which in this case is x. So you got to get in the habit of identifying c first. That's the easiest way to do these. So identify c first. That's the hypotenuse. C is the hypotenuse, which we're really going to jump into more coming up. But C is the hypotenuse. What is the hypotenuse? Well, it's the longest side of a right triangle. So in these three, X, 6, and Z as in zebra are each a hypotenuse of their right triangle. So here we go. X is C, 6 is C, Z is C. So you always want to rewrite the formula first. So a squared plus b squared equals c squared. That way, all you have to do is just input the values for a, b, and c. I like to start small. So my smallest leg I usually do as a, the middle b, and the largest, of course, is c, like we just talked about. So small, 3 squared, middle, 5 squared equals the longest squared. Three squared is 9, 5 squared is 25. Just bring this down. 10 plus 25 is 35, so 1 less is 34. Equals x squared. And then once you get here, it's a little tricky, but all you gotta do, might as well use the orange, is take what's called the square root. But you have to do it to both sides, so don't forget that. So let me go get a calculator, and then we'll finalize this one. So, second, x squared, 34. Close your parentheses. Enter. 5.830951895. Let's just go 5.8. Square root of x squared is just x. So we're going to say x equals 5.8. All right, let's do this one. Remember, first step, just rewrite Pythagorean. It allows you to organize things too. Good principle of good math work is that it's very, very organized. All right, so small side is 4. So 4 squared. Next biggest side is y, which we're going to call b. And then remember, c is the longest side. So 6 squared. Now this brings me to like, how do you easily identify the longest side? The easiest way is to observe where the right angle is, the 90-degree angle, and then the hypotenuse, or C, remember C is the hypotenuse. Are you ever going to see the word hypotenuse outside of geometry? Maybe. Maybe, if you're get into construction and you need a support beam for like a window or something. Maybe. But the easiest way to identify the hypotenuse is it is the one that never, it's the side that never touches this right angle. Never touches this right angle. There it is. Okay. 4 squared is 16 plus y squared, we don't know yet. 6 squared is 36. Now I'll run how you can easily do that. Just hit 4, then hit the x squared button. 16, 6, x squared button. 36. Boom. Real quick. So don't let little things like trip you up. Sometimes you'll have like long decimals or something that are hard to compute, but as long as you know how to use this calculator, save yourself a ton of time. All right, so 16 plus y squared equals 36. We got to get this y squared by itself. We got to isolate y. That's how you solve for y. So let's subtract 16 to both sides. Make sure you do it to both sides. The reason being, these cancel out because 16 minus 16 is 0. So you're going to be left with y squared equals 36 minus 16, which is 20. Again, use a calculator if this is like too much mentally, and that's totally okay. Some people don't have those calculator brains, and that's, again, totally okay. It's not all that common. Now, you gotta, when you have a y squared, you gotta take the square root of both sides because the goal is to solve for y. And this is gonna get y by itself because the square root of y squared simply equals y. Now let's get some practice with square roots. So square root of 20 is our goal. So you just go second x squared 20, enter. And you'll get 4.472135955, but let's just round it. So 4.47 will round to 4.5. You always round up if this is 5 or bigger. So 4.5. That's what y equals. So we got x, we got y. Now let's look at z. And this is where this comes in. At this point, in this figure, you've got the 3. Okay, that's one of the legs. Z is unknown because they gave you a letter for it. So anytime you see a letter, that means we don't know what it is. So we got to solve for it. And JG is blank. So we don't even know what JG is. So up until this point, all I've taught you is Pythagorean theorem. In Pythagorean theorem, you need 2 sides to solve for the third. You need two sides to solve for the third in Pythagorean theorem. Let's count the sides. We got 1, 2, 3. How many do we know? We only have 1. The 3. So, up until this point, imagine you haven't learned this yet. On this one, you're going to say, not enough information. I need one more side to use Pythagorean. Since you only have one side, technically you don't know how to solve for z, but I'll give you a little glimpse into the future. Look at that 50-degree angle. See that 50-degree angle? You can start identifying sides. So z is the hypotenuse. JG is opposite side from the 50. 3 is known as the adjacent leg. You could run cosine of 50 degrees equals adjacent over hypotenuse. So you can say cosine 50 equals 3 over z. This is next up. This is the near future. And it's called trigonometry. In high school, trigonometry, so, ka, toa. You might even remember this 20 years from now, so, ka, toa. You might. That's my best way to summarize high school trigonometry is so, ka, toa. We'll get into it, don't worry. All right, let's move on to the next one. Is it accessible? Okay. So, some buildings offer ramps in addition to stairs, so people in wheelchairs have access to the building. What characteristics make a ramp safe? Now, we're talking about wheelchair ramps. We're not talking about skateboarding ramps. So think about ramps for folks that are in wheelchairs. This is really, really important, especially if you're going into building or construction. See these stairs right here? Being able to get upstairs is a privilege. Like, it's something that you shouldn't take for granted. It's so much more work trying to get up this ramp. So don't take things for granted. Just simply walking up the stairs is something that you should think about being lucky to be able to do. Some people can't. So, but they still got to get places, obviously. So they build ramps. So let's think about what characteristics. That's the key word here. And this is almost, I suppose, a metaphor for one of my favorite teaching principles, which is get everyone to 100. Make sure everybody understands before you move on. Make sure everybody can get where they need to go. It's a big thing on inclusivity. And we're going to find out soon it's part of our laws. Because we're going to look at the ADA, Americans with Disabilities Act. Okay, so what characteristics make a ramp safe? Well, let's see. Number one, not too steep. That's a good one. You don't want a super steep ramp. What else? Wide enough for a wheelchair. What else? Smooth surface. How about it's got to be a straight angle? This needs to be the same angle the whole way. Like it's got to be straight angle. So this needs to be like flat and smooth. What else? Few obstacles, if any. These are bricks. Luckily, these rubber tires will get through bricks, but an even better one would just be straight concrete. Because concrete's got fewer like gaps. So few obstacles, if any. Small or no cracks. And let's just call it the pavement. Small or no cracks in the pavement. What else? Anyone notice this handrail? You want a handrail on it so that what if this guy looks away or something and like rolls off the side? Like that person could get injured. So railings for safety. You gotta start thinking about other people and not yourself. I don't think about these things. I'm not in a wheelchair, but who knows? Maybe I'm out snowboarding and I hit a tree or something. And I'm in a wheelchair the rest of my life. I'm gonna start thinking about these things. So, anyway, characteristics for a safe ramp. There's 7 for you. Okay, now it's time for ADA. So, the Americans with Disabilities Act has some legislation that builders need to follow. The first one is that for every 12 feet of horizontal distance of a ramp, the max elevation is like 1 foot. So essentially the ramps, if you think of like a ramp, that's always going to be a right angle. But the ramp itself, let's say this is the ramp here. This is the ramp up. The ramp itself, the legs have to be in a ratio of 1 to 12. This angle right here, the max, RIP Max, that was my German Shepherd, but the max angle is 4.8 degrees. That's tiny, 4.8 degrees. That's really, really small. Think of a 90-degree angle. We're talking about a little tiny sliver right here. The max angle is 4.8 degrees. The width, think about this wheelchair right here. How wide? That's probably like 2 feet at least. So the width has to be 36 inches or more, because you gotta have room to get up the ramp. So there we go. The width, it's gotta be 36. If you look at this drawing, here's your right triangle right here. It looks a little different because this is real life, so although that doesn't look like a right angle, it is. But essentially, here's your drawing of your ramp, which is very similar to this. So this is 90, this is 4.8. If this is 12 feet, this is 1. If this is 24, this is 2. Okay, I just got a notification I'm low on battery, so I might have to speed up a little bit. But a school has 4 steps to the front door. A school. Let's just call this leadership. Public schools. Leadership public schools. We got a school, right? Like a walkway up. And then there's 4 steps to the front door. So I used to always love drawing steps. Okay, 1, 2, 3, 4. Could have been better. Oh well. 1, 2, 3, 4. Oh, this is a bad stair drawing. Oh well. Bottom line is you got a 4 stair up to the school, right? Maybe there's a dude skateboarding right here. I used to love 4 stairs. 4 stairs were my favorite. Kick flips, heel flips down a 4 stair. Anyway, maybe throw a handrail in here, because that would make it safe for people walking. Do a kick flip over the handrail. Anyways, 4 stairs. Each one is 7 inches. Each step is 7 inches. So you know, if each step is 7 times 4, this total height is going to be 7 times 4, which equals 28 inches. All right. So we're going to have to build a ramp for the school to get to here, right? So imagine they had a ramp like, I don't know, right here. This is your ramp up. So everybody can access it. Now just think, right triangle. We know the height is 28. So that's 28 inches. We know the width has to be 36 inches, because that's part of the law. You gotta solve for this one. How much horizontal distance, essentially? So imagine, here's your ramp. What is this leg right here? Well, you know, it's gotta be 12 to 1. So ours is 28. right triangle, right triangle. Now, you know from the legislation, this has to be 4.8. So, this is ADA right here. 12-to-1 ratio, the legs, 4.8. It's gotta be 36 inches wide. But we've got to get 28 inches. So you know the width is going to stay the same, 36. Now, look at these right triangles right here. Two highlighted right triangles are similar. That and that are similar. Why? Because you get the 4.8 and the 90. What is that theorem called? The angle similarity theorem. Look at this. Angle similarity theorem. Real life wheelchair ramps. Every single building. Well, most buildings require a wheelchair ramp. So these are similar triangles, right? 1 to 12, 1 to 12, 4.8, 4.8. Now you gotta solve for x. Remember, in similar triangles, the ratios of the sides remain the same. So you can just say 1 over 12 equals 28 over x. And if you missed that little concept, just look back. We just did that in 1.1. If you need to, just rewind like 30 minutes. But anyway, 1 over 12 equals 28 over x. We are almost there. Let's go ahead and cross multiply. X times 1 is x. That will equal 12 times 28. Don't try to do that in your head. Although the easiest way would be 12 times 30 minus 24. But here we go. What's 360 minus 24? 336. All right. 12 times 28. X equals 336 inches. Don't forget, that's the double prime would be your inches logo or symbol. So the last thing is this 336 inches. There you go. This is your final ramp. It's not a perfect right triangle. Don't knock me in the interest of time. Here's your wheelchair ramp. $36 for the width. 336 the horizontal distance. 28. This has to be 4.8 degrees. If you're the construction manager, you got the job. Build it now. That's where I can't help you anymore. I don't know how to build. But I bet I could figure it out. Anyways, this is your final ramp. And remember, the world doesn't revolve around you. You got to start thinking about how it would be in somebody else's shoes. All right. Have a good day. Bye.